Welcome to 1.5, page 2. By this time, we've gone through these problems. There's some domain challenges in this number, particularly in number 16 and 18, even more so. But we'll go ahead and we'll clean some of that up as we're moving on through the remainder of this chapter and this semester. But these are pretty straightforward right here. F minus g of negative 2. I'm given f. I'm given g. F minus g of negative 2 is f of negative 2 minus g of negative 2. And when we're doing this, we want to use parentheses for these things. F of negative 2 becomes negative 2 squared. F is a factory that squares things and then subtracts 1 minus, that's just a habit I have on this, minus, it's a good habit to get into, g of negative 2. G is a factory that takes things and subtracts 2. It takes this negative 2, subtracts 2. So we get 4 minus 1 minus negative 4 plus positive. That's 8 minus 1, 7. And that's it. So top of the page, not too bad. Fg of x is, or of 4, is f of 4 times g of 4. F is a factory that takes things, squares them. 4 squared minus 1 and multiplies by that. G of 4. G of 4 is a factory that takes things and subtracts 2. So we get 16 minus 1, 4 minus 2, or 30. 30. And now we get a little bit of a sneakiness to this. F is a factory that takes things. So first we'll write this as f of t minus 3 plus g of t minus 3. And here's the mistake I will see. They'll say, well, I guess that means that we're going to have a t squared minus 1, t in place of x, and then we have to put a minus 3 after that. So we get t squared minus 1 minus 3, but it's not. This is the thing. And f takes the thing and squares it. So we take that whole thing, t minus 3, and square it. T minus 3 squared, and then subtract 1. And then we are to add to that g of the thing. G takes the thing, t minus 3, and subtracts 2 from it. So let's see, foiling, t times t, t squared. I get a minus 3t and another minus 3t, minus 6t, plus 9, still minus 1, plus t, minus 3 minus 2, minus 5, for t squared, minus 6t's plus a t, minus 5t's. And notice how I make my t's with the little loops on the bottom. I do not want to get a t confused with a plus, and as we move on in math, and particularly into physics concepts, we use t all the time for time. So let's see, t squared minus 6 plus 1 minus 5t, and I have a 9 minus 5 plus 4. Which factors do not feel compelled to leave your answer in a factor as factors? This factors into t minus 4, t minus 1. If this was set equal to 0, factoring makes perfect sense, but this is completely acceptable answer. So f of t plus 2, or f on g of t plus 2 is f of t plus 2 on g of t plus 2. F is a factor that takes the whole thing. Oops, don't want to do that yet. I was going to do 2 steps in 1. Takes the whole thing, t plus 2, squares it, subtracts 1. Takes the whole thing and squares it, subtracts 1. While g is a factory that takes the whole thing and subtracts 2. T plus 2 minus 2. So we get in the numerator, FOIL, t squared plus 2t's plus 2t's plus 4t plus 4. We still have to subtract the 1. All on G is t plus 2 minus 2 is just t. So t being 0 wasn't really a problem for F. It wasn't really a problem for G. T being 0, 0 was fine here, 0 is fine here. But now, putting 0 in for t we see as a problem. We end up with t squared plus 4t plus 3 on t, and once again this factors t plus 3 times t plus 1, but there's no benefit in factoring because I'm not going to get a factor of t to cancel. So there we have it. Should you state that t can now not be 0? In all honesty, you don't have to, because a reader at this level should see, oh, I can tell t can't be 0 because the final answer reveals that very easily to me. Okay, now, this would actually be a good place to have a new page here, but here's my diagram I said that I would mention. FOG, that means, you'll see it this way, FOG really means f of g of x. And here, I like this so much better because it paints a better picture. Sure, that's abbreviated. But f of g of x, to me, means this. I'm going to take x, I'm going to run it through a factory named g, and out of there, I'm going to take the results of that and put that into a factory of f. So we're supposed to, and again, not going to want to write real big here, we want to find f of g of x. That's what FOG is, f of g of x. I'm going to readjust here a little bit. Run out of some space on my desktop. Okay, so that is f of, well, g of x is x cubed plus 1. Oh, okay. Well, f is a factory that takes this nasty thing and puts it right here. So the third root is still there. In place of the x, I'm going to put in x cubed plus 1, and then there's still a minus 1 in here. All of this is in the factory. What's not in the factory is the thing. The thing that goes in goes right there. So this, we quickly see the 1's cancel, third root of x cubed. This is just x. So what we have here is f just undid what x did. This is a preview to a section that we're going to be covering pretty quickly. If I take 5 times x and then divide by 5, we get to x. Therefore, 5 and 1/5 are referred to as inverses. They're multiplicative inverses. This divided by 5 undoes the 5. These functions are actually called inverse functions of one another. B. Now we want to find g of f of x. That is g of third root. Here's what f of x is. X minus 1. G is a factory that cubes things, so we take the thing, third root of x minus 1, we cube it, it takes the thing, cubes it, and adds 1, and we see that we get the cube cancels the third root, x minus 1 plus 1 equals x. And right now, the scientist, not the mathematician, the scientist in our head should be saying, hey, I wonder if f of g of x is the same as g of f of x. And then we're supposed to find c, f of g of 0. Now, what we could do is, watch this, we could put 0 into g, and we get 4, clearly. And then take that 4 and put that into f, and I get 2 times 4 squared, 2 times 16, 32. However, we've got, was I looking there? Oh, this function, silly. I was looking at 41, excuse me. I'm not going to redo this video. Watch this, I can put 0 into g, and I get 1. turn around and put 1, the result of that, into f, and I get third root of 0, I get 0. And that's fine. However, we have already built the f of g of x factory. F of g of x is a factory that if I couldn't see what's going on and I just went and dropped x off here, it goes through g, it goes through f, and what comes out is x. So if I put in my pen there, what's going to come out is pen. F of g of x ends up not changing the thing that we start with at all, so f of g of 0 is 0. We built the shortcut. It's interesting that I ended up referencing 41. All right, long day. 44a. First, I want to find f of g of x, and f of g of x is f of g of x is 1 on x, and f is a factory that takes things and cubes them, so I get 1 on x cubed, which is 1 on x cubed. And that's it. And I notice x can't be 0, but x couldn't be 0 in g anyway. B. G of f of x is g of x cubed, and I get g of x cubed. G takes things and puts them underneath here is 1 on x cubed, and once again I'm saying, wow, maybe it doesn't make any difference what order we do these things in. Well, stay tuned on that thought. And C, we're supposed to find f of g of 0. I'll do this the right way now. Well, 0 was a problem. Couldn't put 0 in g to begin with, so this is undefined, and we notice f of g of 0, if I use my shortcut here, oh, I can't put 0 in here either, so we are undefined. So I guess that's why in the directions they say if possible. So practice your small, neat writing on 19 through 43. This was a 12-minute video and probably should take you somewhere along that time, perhaps a little bit less. Stay tuned.